Welcome back, everybody. Now it is with great pleasure that I welcome our second speaker, Andrew Jeffery.
Hi.
Andrew has spent 20 years working as a teacher, is that correct? And about 11 years as a teacher trainer, I think. And Andrew travels to all parts of the world. He works with children, with teachers on mathematics in primary education. He's very passionate about the subject. And Andrew will focus on why the Singapore maths approach is so effective for learning. Welcome, Andrew.
Thank you very much, Louise. Hello, good afternoon, buenas tardes, and so on. So I am very excited to be here, and I want to spend just a few minutes with you talking about what it is that some children find easy, others don't. In Singapore, they seem to have this good record, but of course, one of the things we know is we can't just simply copy what someone else does and expect it to be brilliant. My wife's got a lovely dress and it looks better on her than it probably would on me. So you can't just do that. So let me tell you what they do first of all. And I want to start with an analogy, if I may. So building a house. When you build a house, there's a very set way to do this. So you start with your foundations. It sounds like a good thing to do. Only when you've put the foundations in can you add the walls. And only when you build the walls can you put the roof on. Now this is fairly common sense, and this is how they've designed the curriculum in Singapore. They started, because Singapore is a very young country, it's only 50 odd years old now, so they were able to kind of take what they knew and rebuild from scratch. Most of us have had to build on top of what we already have. They had nothing, so they were right from the go. Okay, now let's say you want to build a curriculum, which is what they did. The first thing to do is your foundation, and that is the concepts. What are the concepts? What concepts do we need to learn in mathematics? And there's a fair amount around the world of agreement about this. So you're not going to find too much disagreement. These are the kind of things you're going to look at: number, algebra, geometry, statistics, probability, and analysis. Some people think statistics isn't maths, others don't. The jury's out. Okay, but once you think, right, those are the concepts. Now, what specifics do we need to get into? And the answer is there are two types. So there's the skills you need, and the processes that you need to go through. And this is about fluency. This is about the kind of things like calculating, being able to manipulate algebra, knowing the rules of algebra, knowing the rules of data, how to find means, measuring things, estimating things, getting a sense of number, in other words. The processes are similar, but instead of the fluency, these are more like reasoning as well. So the bar modelling we'll come to if we have a minute, but thinking skills, that's the kind of thing. They're very keen on asking children, think about what you're thinking about. And their answers are always something because. The answer isn't 12, it's 12 because it has to be half of 24, that kind of thing. Okay, so reasoning's important. And then finally, you can put the lid on that. And attitudes are extraordinary. I've sat in Singapore classrooms, and they're very much, no one knows you are living, you're proud to be Singaporean, all the lessons are in English, they think that's important. But confidence, for me, confidence has always been the number one issue in a maths classroom, if I'm honest. Confidence of the adults in the room to take it where it'll go, confidence of the children to have a go. And metacognition is just a word that means think about what you're thinking about. Or as John Mason from Oxford would say, attend to where your attention lies. All right. So, for example, there's a school, not in Singapore, but a school I've been to many times in Brunei, where at the end of the lesson, children will often be asked, were you working in your comfort zone today? Were you working in your challenge zone today? Or were you working in your danger zone today? And that's really important. We want to be in our challenge zone. The other two are no good for us. So this is what it's about, problem solving. And to that extent, I find a real kinship with the Singapore approach, because their curriculum is founded in problem solving, and so is ours. The three aims of our curriculum in the UK are fluency, reasoning and problem solving. And this is something that's been taken on board by many people. And I think fluency and reasoning support problem solving, but the reason we learn mathematics in the first place is because we want to become problem solvers. In fact, as a species, we've got so good at mathematics that, to be honest, that's why we've succeeded, because we are problem solvers. We're very good at solving problems. You might say we've caused most of them, but we solve them as well. So now it's time for you to have a say. So here's what we're going to do. I know that when people first started talking about Singapore, they had very fixed ideas. And often what you get when you find something new is the headline, the stereotype. But whoever you are and whatever your perspective are, just try and come up with 3 words. That's what I want you to do. What are the first things that come to mind? And then we'll unpick some of those ideas.
Okay, so that question will appear on your screen in a window. And the question is, what 3 words come to mind when you think of Singapore maths? We'll give you 20 seconds, more or less. 20, 30, to answer. Singapore maths, personally,
yeah, go on, what would you say?
I would say something experiential.
Okay.
I would think of maybe large classes as well.
Mm-hmm.
But I'm conjecturing,
And that's all I want people to do. That's all I want people to do.
That's based on my preconceived ideas.
Yeah.
Complicated to manage if you've got large classes.
Okay.
Yeah.
Okay.
Let's see. Somebody says here, friendly understanding. That's interesting.
That is.
Yeah.
Yeah.
So they perhaps are thinking that there's a good relationship between the teacher and the pupils, and that there's...
Yeah, sounds like that.
Yeah, support.
Okay. So there is understanding now. Friendly is very subjective, obviously.
Yes,
I'd like to think so. I think life is about relationships,
yes.
And we don't. It's a myth that we have to like the teacher to learn from them. But if the teacher respects us, we will sense that, I think.
Yes.
I mean, I look back to my childhood, and I learnt from the teachers who had a command of their subject, and wanted to get that across to me. I didn't like them all.
No.
And there were some teachers I liked because I thought they were cool and fun, but
Yes.
I didn't necessarily learn from them.
Yes, that's
However, I think friendly is actually... You're not a friend to the student, but you could be friendly. I think it's respect.
Yes.
There's a culture of respect, but there's also a culture of real expectation as well. This idea that they have very much in Asian cultures is, you need to work very, very hard at school, because then you will get to a better secondary school, then you will get to a better university,
Yes.
then you will get a better job.
Yes.
There's that real culture. And I see it as well. I live in the UK, and you can see those children who have come to the UK from Asia, their work ethic.
Yes.
You can see that within them.
Yes.
So yeah, that's good. And what was
Yes.
the word after friendly?
There was another problem solving.
Definitely problem
Yes.
solving, yeah.
And meaningful learning from Monica. Thank you, Monica. And John is saying experimental, so hands-on in some way.
Definitely
first-hand
hands-on.
experience.
Yeah. Okay. So
Great.
because of my memory, I'm going to have to refer to your list. So
Yes, no, that's, experience.
problem solving is absolutely it, as you said. The second one was...
meaningful learning.
Yeah, no, meaningful learning. I'll unpack that a bit, because I like that. And meaningful learning is something that you can relate to, because I've been thinking recently, we ask children to think. Come on, think. Okay. But before we ask them to think about something, we must provide them with an image to allow them to think. And this is the whole thing about Jerome Brunen's theory, which we're going to come on to later, the concrete pictorial abstract, which is actually one way of thinking about maybe even more deep. I mean, Brune didn't call it that. He called it enactive phase, iconic phase, and symbolic phase. But actually, I like even better the idea of manipulating something, getting a sense of it, and being able to articulate. And so language is really, really important as well. What was the last one?
It was experimental.
Experimental. They don't experiment as much as you might think, but they do go very deeply into subjects.
Right.
So not at primary level.
Right.
But I suppose if you're talking about, if the respondent there is talking about experimenting with equipment, practical
Yes.
equipment, then yes, to get an image. Because how do you think about something you've never
Exactly.
seen?
Something
right.
that's abstract.
Yeah. All right. So thank you. That's an interesting
Great.
way
Thank
to
you.
crack on. Right. Now I want to show you this. Here's something which you might say was experimental. I want to tell you a little story now. I don't know if anyone's on the call from Rome. If you are, you can put a little chat in Louise's comments. But this is a photograph I took in a grade 1 class in Rome. So we're looking at 5-year-old, 6-year-old children, and taken with permission, obviously. And I walked in and there was this lovely rug on the floor that you can see here. And I've always been slightly sceptical of 100 squares. Not the numbers themselves, but the way in which they're used. Because if you think about the highest numbers, they're at the lowest position, and that can be confusing language for a young child. And to go up, you actually go right. Yeah, and to go up 10, you go down 1, and this is there are dangers inherent. However, there is some structure visible as well. But I also saw a box of plastic shapes on the wall of the class, on the windowsill of the classroom, and I said to this little boy who happened to be near, I said, "What are those?" And he said, "Oh, they're Numicon shapes." Now, I know quite a bit about those shapes, and but I sort of slightly cheekily said, "Oh, what do you do with them?" And he said, "They're numbers." I said, "Oh, I thought those were numbers," and pointed to his rug. And he said, "Well, they are, kind of." So I picked one up and I said, "What's this?" And he said, "It's 8. And so you can see from the picture what happened next. So I said, "Oh, put it on the 8. And I said, "What would you put there?" pointing at the 18. And he said, "Well, there isn't one for that, but you can make it." And so what he was able to do was manipulate the numbers in a way that he couldn't have done without the resource.
Wow.
And so and you can see the beautiful pattern there. His friends started to join him, and they realized that 28 was exactly the same as 18, but just one extra 10. And you can't see that just from looking at the symbols. So this is a really crucial photo. There's a lot of depth going on and I was so excited to capture this little moment of learning. And of course, as you can see, his mates come over and start asking him what goes on. And the really exciting corollary to this story is the year 1 teacher said to me, she said, "That was just so amazing." And I said, "What was?" She said, "That boy has particular learning difficulties. He's never concentrated on anything for more than 1 minute before." She said, "But because he was able to tie what he was trying to learn to something he could physically get a sense of." Does that kind of help?
Yeah, no, that makes perfect sense.
So that's really something they're very good at. So in a sense, that idea of experimenting that your correspondent came up with, that's a really good.
You've elaborated really well on that.
Okay, so so there's a clue as to what they're doing now. They start off with an idea of problem solving as the goal. So you can teach through problem solving, you can teach for problem solving, or you can teach as problem solving. And so what they do is they start very much from problem solving. They emphasize, as you can see here, the idea of visualizing numbers. So we can, I won't go back to that image before, but you can see what's going on. And someone else kind of alluded to this idea in different words. The emphasis on conceptual understanding. I think they used the word meaningful conceptual understanding, and I think this is so missing in so many children's mathematical experiences. It was for me at school. Now I had some really good teachers, but I was lucky. They were good for me because I could get what they were talking about, but other people hadn't made those visual connections. So effectively your brain thinks in 2 ways. It thinks in imagery and it thinks in conversation. So if you think about thinking as having a conversation with yourself, you need the right vocabulary, but you need the right things to think about. I remember my university lecturer saying, "Can you think about an elephant?" And I said, "Well, yes, I can." And he said, "Can you think about a krasnal?" And I said, "No, I can't." Not because a krasnal is a more difficult idea than an elephant, just because I didn't know what one was. Okay, there we are. And this is the thing. If you know what one was, you're not cleverer than I am. You might very well be cleverer than I am, to be honest. But if you know what one is, it doesn't make you cleverer just because you know it. But it does allow you to think about it and reason about it. Okay, now this idea of spiral development, this is very important. So one of the issues I have with 1 or 2 published schemes of work that I've seen is that they say, "Right, we'll do a block of this, then a block of that, then a block of that," and that's not really how we learn. The best thing to do is, you have to initially have a little block of it, but you must connect it to something else, and you must revisit. I saw a lovely quote. I was working in London yesterday in a secondary school, and I saw a lovely quote on the wall, and forgive me, I can't attribute it to whoever it was, but it was effectively saying, trying to learn something without constantly reviewing and revisiting is like trying to run a bath without a plug-in. I just thought that's really good.
Excellent.
It is excellent. If anyone knows who said that, please just
I'm going
type
to remember
it
that.
and send it to Louise, because I forgot to see who said it, but I think it's really good, and that's what's behind the idea of a spiral curriculum. Revisit things, give them like a very low stakes quiz a few weeks later to see what they can remember. I think one of the things I got wrong in my teaching career was at the end of a unit of work, I would test the children on that unit of work, and they'd all do really well, and I would pat myself proverbially on the back, going, oh, they've all learnt that. And of course, a few weeks down the line, they hadn't really. They'd remembered. And remembering isn't the same, all right? So we want to change long-term memory. And conceptual understanding will do that. Once you understand something, you don't have to keep remembering it over and over. I go back to my old days of programming a VCR. There you go, just giving away my age a bit there. You know, these days it's a click, record the entire thing. Too. But I had to relearn it every single time because it was such a... Get the book out, record this. Anyway, things have moved on. And the CPA approach, which we've talked about. Okay, so let's have a look now at the format of a lesson, if we might. So they are of this theory, this principle, and actually they would be the first to tell you in Singapore there's nothing particularly new about this. So there is an initial teacher input, and I think since the beginning of education itself, the initial teacher input is the teacher saying, I do. I'm the expert in this classroom. I'm not ashamed to say I'm the expert in this classroom. I'm going to do a bit. But then, as I think Bob alluded to, the whole lesson can't be like that. Otherwise, it's just like delivery. So then it's we do. So look, you've seen me have a go. Now we're going to have a go together. And then you're going to have a go. So we're effectively going clockwise around this loop. All right?
Yes.
And but what I like about this model and why I've drawn these arrows the way I have is because they're double-edged. You can change direction. And this is, I mean, any good teacher will tell you. In fact, I suspect everyone on this call right now can think of a lesson that you've planned meticulously, and then within about 3 minutes of it starting, you go, nah, I think we need to go back a little bit, actually. Fractions, never done them, miss, So we've all done it. And so this is the skill of the teacher, isn't it? But these are effectively the three phases of a lesson. And we would aim to start where I do, then we go to we do, then we go to you do. Now, talking to teachers in Singapore, what I learned was sometimes they actually start at the we do. They actually start at the we do, and that's because they're not at the very beginning of a concept or a topic. Right. So you don't need to go back in and go, right, now I'm going to show you something. You just, do you remember what we did yesterday? Let's have a go at it, blah, blah, okay. But if you need to go back, you can. And sometimes, as we all know, you need to go, okay, well, stop everyone, sorry, that's just my bad, I didn't explain that. What I actually meant was da-da-da-da-da-da. And that's the craft of teaching. There's a big debate, is teaching an art or a science? It's a craft. That's what I think it is. It's a craft. There is art and science to it. I digress. What I like about Max Math, which obviously Macmillan have produced, is if you look at what their structure is, they don't call it that, but the idea is the same. So there's teacher input there, then there's the let's learn together. Let's have a crack at this, guys. And then let's try it. Now, the try it is the independent idea. And again, the arrows remain. So I hope that's kind of a clear thing to do. To show you the structure. It's not new, it's just good common sense. Now, common sense isn't always common, of course. What I want you to do is just try something for me. So wherever you are, just whatever you have to hand, grab 3 objects. Just 3 items, it might be pens, it might be pencils. Gives me a chance to slug some water attractively. And now we're going to do some maths. And the maths we're going to do is simply take a 4th item and place it with them. That's it. Now, that's not the most exciting bit of maths you've done today. Maybe it is, in which case, do more maths. But there you go. So we've done that. We've put 4 things together. And now, if I asked you to draw a picture of that, you can do it if you want, or just wait and watch. That's fine. And you'd come up with a diagram, some kind of image. It wouldn't be a photograph of it, but it would be an image that represented it. And then if you know what a PartHold Diagram is, you could draw one of those. If you don't, hold on, you will do by the end of this. And then draw an equation, or write an equation. Now, those simple things are all more or less the same piece of mathematics. But this is behind what Jerome Bruner said. So this is what concrete, pictorial, abstract actually looks like. Let me take you through these phases, because it's very simple. Concrete, physical, I actually do it, okay? Even though my concrete cubes are actually made of plastic, not concrete. Concrete is something manipulable. I can physically move it. Like these, like Dean's blocks, like straws, like the Numicon shapes, like the place value arrow cards that you see. All of those things are practical resources. Bead strings, lovely. I saw a beautiful bead string activity done by a grade 6 class this morning. They were working out the connection between fractions, decimals and percentages. And it turns out it's a very easy thing to do on a bead string. Then you drew a diagram, and that's the pictorial. Now the part-whole model is, you can see the 4 on the left, meaning the whole, and the 2 parts on the right, the 3 and the 1, making that whole. And then finally, the most abstract of all, the symbols, the 3 plus the 1, and then that funny 2 parallel lines, which we know means is worth the same as 4. And that's the theory. That's the theory that that Bruner came up with. Okay, so let me ask you now, talking of these practical resources, I want to see who's using these. Now, I've just put a list because these are 5 of my favourites, but you might have others. So just literally take a few seconds and just think. Don't give me an answer for, oh, he'll want me to say that. Literally, I'm just genuinely interested to see who's using these resources. So plonk us some answers.
So this will appear on your screen, the question, which of these do you use the most? And you've got different options: Numicon, Cuisenaire rods, dinesh blocks, I'm not sure if I'm pronouncing it correctly, straws, and place value cards. So we'll give you 20 seconds, 30 seconds to complete that.
Oh, you get percentages?
Yes.
Oh, that's very high tech.
Oh, it is, isn't it?
What you can't see is there's a whole raft of high-tech guys around here just being awesome. Okay.
Oh, wow. Cuisenaire rods are coming out as... no, it's going down.
Yeah. Oh, but that's because, if the first person to vote says Cuisenaire rods, they get 100%. That's how it works.
Okay, so 60 at the moment, 67% are saying Cuisenaire rods. Numicon is going down to 25%.
I'm really excited by it to see this, because Cuisenaire rods went out of fashion in about the 70s, 1970s.
Wow. Did they?
Mainly because I think it's not at all obvious how to use them.
No, true.
And the thing with practical resources is they are only a proxy for the mathematics. They're not the mathematics.
Sure.
And there's a very strong danger that we can get addicted to them.
Yes.
And then they become our kind of safety blanket. So they are a tool for a time.
Okay.
They are a tool for a time.
Right, okay.
Like training stabilizer wheels on a bicycle.
Exactly, yeah.
Or somebody once said nappies, diapers.
Oh, right.
They're a tool that does a job until you learn to think for the way.
I'm showing my age now by saying, what about abacuses?
Yeah, what about them? Yeah, in fact, the best ones are the Chinese ones where you push them together, the pawns together.
Yes.
But another one, maybe another time for that.
Yes.
Okay.
So yes, it seems like a majority are saying Cuisenaire rods, 80%, and Numicon 20.
Okay. So let me tell you why you weren't that far. When you said Dean, I call them Dean's blocks, but even that's not correct because they were invented by a Hungarian professor. But the British are notoriously bad at pronouncing anything in any other language. And we all call him Deans, but his name was Zoltan Dinesh.
Oh.
So there you go. You can impress your friends in the staff room by saying, I'm going to get out the Dinesh blocks now. And try not to sound too pretentious when you do that. So, but they are the ones, tens, hundreds. They are the things that show. And in fact, they use those extensively in the Singapore approach. So in Singapore, you'll see all of these kind of things being used. And I will talk to you a little bit about that now. So the very beginning of grade 1, notice, if you look closely, you can see concrete, pictorial and abstract straight away there. Okay. In fact, they've jumped straight to pictorial, to be fair. But by the time they get into that, they've done lots of counting of objects. And even counting itself breaks down into 4 different stages. Those are pre-grade 1 level. All right. So this isn't really the time to talk about that. No. We could do a whole session on just the mathematics of counting, because it's one thing I will say is if you teach younger children, counting is a very difficult thing to do and understand. It doesn't feel like it to us because we have memorized counting, but it is. It's actually a really tricky thing. So you see the different representations straight away. Let's pick a random line. Let's take the middle line there, 3. So I have got 3 objects. I've got the numeral 3, I've got the word written in English 3, and I have 3 countable dots. Now the paradox is none of those are 3, but they all represent 3 in some way. Rather like a musical note written on a piece of paper is not the actual note, you can't hear it, okay? And that's really hard. So right at the beginning of the Singapore textbooks, and in fact Max Maths have done exactly the same here, you'll find this idea. So right from the very beginning of their mathematical experience. But it doesn't just stop there. There's a myth about the CPA approach, Louise. I want to address this.
Yes.
In many schools I've been into, what you find is lots of resources for the youngest children and slightly less for the older ones, as though you don't need them anymore, as though you're too clever for them now. And often further up, it's just the children who are struggling have equipment. And that's really not what Jerome Bruner's theory was all about. And you won't find that happening in Singapore. So what happens is, here's an example, all right from the highest primary level. So we're looking, this is a page, I hope you can all see this page okay. This is a page from the grade 6 book. And it's actually about factors and primes and composites and really important mathematical ideas, but it's done with jelly beans.
Okay.
And you know, when I was at school, there was no visual thing about factors. No. And if you just have a look at this, the idea that you can arrange 10 jelly beans in 2 ways, 2 rectangles, right? 1 by 10 or 2 by 5. And those 4 numbers that I just said turn out to be called the factors of 10. Sorry.
Wow.
Yeah. And then you look at the second example, Padma with the yellow one, she's got 7 and she can only arrange them in one array. That's what we call a prime number, if you can only arrange them in one way. So you see, this is what's so clever. Instead of saying, there you go, instead of saying, okay, we're going to learn about prime numbers today,
just remember
what the heck are prime numbers, There's no, do you see what I mean about, don't ask them to think about something until you've given them something to think about.
But you're asking them to manipulate it, to be able to reach that understanding.
Yeah, you are. Yeah, fantastic. Exactly. They manipulate it, they get a sense of it. And what's lovely, of course, eventually, I mean, I do this with little square tiles. And eventually, because I like the idea that you can then talk about area.
Yes.
Because if you do them with round counters, which is a traditional way to do 2-dimensional arrays, you can't really talk about the area. If I do a 4 by 3, it hasn't got an area of 12, whereas little square tiles it has. And so that's an extra thing. But it works as arrays here. And so just this page shows you the power, I hope shows you the power.
Yes.
Yeah?
And the
getting children
importance
to reflect.
Continuing that through the levels, not just with younger children, but right up to the end of primary.
Completely.
And beyond.
Completely.
Yeah.
I've seen some, if any of you teach like 16, 17, 18-year-olds mathematics, I've seen some amazing lessons for that age group using multi-link cubes. Okay. Really extraordinary stuff. So yeah, they're encouraged to reflect. They keep a journal, and the kind of things they have in there are, I don't say much about these, but there's clear structure. Check your maths is really difficult. You know, I'll be honest with you. In my career, when I said to children, check your work, it was usually because they'd done it too quick and I hadn't got anything else. Oh, well, help. But children find it very hard to check their own. So checking each other's is much better. We all know that when we write reports, it's harder to find our own mistakes.
Yes.
But other people. But practicing math language is the best one, I think. Practicing my math language, because as I said a few minutes back, if you have the right language, it's easier to communicate. Sure. We've all had that experience where you say, I feel, and you're searching for how you feel. If you have good emotional vocabulary, you can share how you feel. All right. And of course, homeschool is important. Now, they have an advantage in Singapore where you don't need to convince Singapore parents that education's important. You know that. Okay. All right. So let's have an example. I like this. I've always worried about the word minus and the word negative. Let's just think about those. So minus is almost like an imperative verb saying, I would like you to subtract now. But negative is more of an adjective saying it is less than 0. Yeah? So negative 3 is the number that is 3 less than 0. But minus 3 means take away 3. So, and that's, you might think that's a little bit pedantic, and it is. Because you need to be pedantic. Math is a precision language. Yeah. So here's an example of where they're bringing in the word negative nice and early, and the vocabulary is listed. They say look at them, write sentences using the numbers so you can compare. You've got greater, less, positive, negative, all of that stuff. And nowhere is there any taking away or subtracting. So minus doesn't get a look in there. All right. That's the language. Now, here he is, Zoltan Dinesh. Okay, let's just look at how he has impacted. That's, by the way, the only piece of art you'll ever see publicly by me.
Oh, really?
He died in 2014.
It's not too bad.
Yeah, no, I know. So that was my idea of a maths joke, if slightly morbid one. There we go, the number 2014. So moving really very quickly on from that. Here's how it translates into class. So I noticed in your poll we didn't get a huge number of people loving these.
No.
But actually I think they're really powerful. Take this number here, 48, the top number. I hope it's big enough for you to read on your screen, guys. But the point is, what's really crucial that Dinesh allows us to understand is that 4 is worth a heck of a lot more than that 8. Because it's 4 tens. It's 4 of something, and here's something you can try. Try this with your classes this week and see how you get on. Put a number up like 48, and that's made of 2 digits, the 4 and the 8, and each digit. We need to know that each digit is effectively an adjective, and there are 3 things we should be able to say about it. Okay, so the 4. Let's take the 4. Question 1: what does it say? And the answer is it says 4. Question 2, what does it mean? And the answer is it means 4 tens. 4 of those things that we call tens. And question 3, what is it worth? 40. And those are actually slightly different questions. Let's take the 8. What does it say? 8. What does it mean? 8 ones. What is it worth? 8. Yeah?
Yeah.
Really subtle.
Well, actually, the 4 is so much more powerful.
Yeah, the 4 is more powerful because it's 4 of something greater.
Yes.
So let's one more example. Let's take the second one. So I've got 65. 6 of those things we call tens. 5 of those things we call ones. So just take the 6. What does it say? 6. What does it mean? 6 tens. What is it worth? 60. The number, the noun. Okay. So I hope that's clear. Now, in terms of the variation, variation theory is relatively recently named, but the practice has been going on for years. Good teachers have been doing this. And what it involves is this. It's changing one thing to allow something to be noticed. So something stays the same, something differs. And in this case, the only thing that's really changed is the equipment used to represent the number. We're still splitting something. If you compare the left to the right, we're still splitting something into tens and ones. We still have a number of tens. This time, though, it's a bead. Okay? It's a bead. That's the difference. Okay, and there is actually something else slightly different about the abacus as well, because these beads on tens are actually the same size as the beads on ones. So that's moving us a little step further. So there's variation built in. This is a year 2 example. Here's a year 4 example. Now, the number 5,609, really clever that they include a 0 in the tens column there. Because there are no tens. Yes. And so again, what does it say? 0. What does it mean? No tens. What is it worth? Nothing at all. Okay. So that's developed into 4-digit numbers. Okay. Now, I mentioned this diagram to you early on, the PartHold diagram, and it's absolutely fundamental to what they do in Singapore. I've seen over the last 3 years a huge growth in the use of this diagram in the UK, and teachers are saying really positive things about it. It effectively means that addition and subtraction are more or less the same thing. They're 2 sides of the same coin, or I like to think about it as looking through the window from the other side. So here's an example. If I was to tell you that there are two parts here, 17 and 3, you'd be able to tell me the whole. And we call that addition. That's just basic. But if I kept the relationship the same, in other words, the 2 on the right are add up to the 1 on the left. If I was to tell you that, then now I'm only going to tell you one of the parts and the whole. You can still tell me what the other part is. The relationship does not change, but the thing that we do not know has changed. And we call that subtraction. And so this diagram allows children, even very young children, to understand that addition and subtraction are effectively about the relationship between parts and the whole. Now, quite quickly we learn that there don't have to be 2 parts, there could be 3 parts, 4 parts, whatever. Okay. The diagram on the right, the product-factor relationship, this is not so prevalent. This is my own design, but you'll see similar things all over the world. So if I know that 6 multiplied by 7 is 42, I should be able to therefore extrapolate that 42 divided by 7 is 6. And also, 1/6 of 42 is 7. Sometimes we don't link fractions enough together. Yeah. So that's that relationship, and it's pretty straightforward, really. Let's have a look at how that looks, and you can see even from year 1, children, and I'm using your Macmillan books to show because why not? Okay, but Singapore, they all do this. So here's my part: 3 red hats, 3 yellow helmets. Sorry, not hats, and there are 6 altogether. 5 green, 1 orange, 6 altogether. Yeah. Right. Okay. Very, very simple, and you'll see the variation there. Notice they'll do things in different colours, and this is important, so it doesn't become that red and yellow makes 6, or green and orange makes 6, which is a danger.
Yes.
Yeah?
People look for patterns, don't they?
Yeah, people look for patterns, and sometimes they're learning something different to what you think they're learning.
Yes.
There was a very good, Daniel Willingham wrote a book called Why Don't Students Like School, which is a bit of a depressing title, in which there was a student measuring the area of his desktop. And to do that, he measured the length, he measured the width, and he multiplied them together, and he did it correctly. So the teacher then said, okay, measure the area of the football field. How would you do that? And the boy said, I have no idea. You've not taught us how to do football fields. Aww. Yeah, it's kind of a sad story, but part of that says to me that the teacher and the child were on totally parallel journeys there.
Yes.
The teacher thought they were doing rectangles, the child thought they were doing desks.
Yes,
yeah?
yes.
Okay.
But there's also the related issue of transferring to other situations.
Yeah, and I think that's a key to mastery.
Yeah.
I'll tell you this, they don't use that word. They don't use mastery in Singapore, they use discovering.
Okay.
Which is great, isn't it?
Yeah.
Yes. I rather like when, I don't want to get too political, but when people from this country went out and said, so tell us what you do about mastery, and they went, what? I better not go too far down that route. Okay, but here's some discovery. Here's some discovery from the year 6, grade 6 children. So again, I talked about variation as what is being made available to be noticed. This was a definition that I got from Anne Watson. And what is being made available to be noticed? And if you just have a very quick look through this page on your screen, pick 2 cards at random from the even pile, find the sum and the difference. And of course what children will eventually notice is that the sum and the difference are always even. But then they do the same from the odd pile, and they'll also find that the sum and the difference are also even. And then one from each, and they will notice that hang on, that's not right, that's not what's happening now, it's always odd, and so on, and then they just develop it. So all the time they're using a resource, but there's guided, structured learning. It's not just the kind of slightly wishy-washy, hey, see what you can find out. You know, it's quite carefully structured.
Step by step.
Yeah. So I kind of really like this activity. I'm planning to do it. I'm going on a tour of Asia next month to do some training. I'm going to do this activity.
It's a really...
Yeah, I think it's quite a powerful one.
It's a very powerful one. It's got a really clear framework.
Yeah. Here's another photograph I took, admittedly quite a while ago now, but I think it sort of sums up the approach quite nicely in Singapore. So if I'm teaching 3-column addition, for example, hundreds, tens and ones, hundreds, tens and ones, the formal layout is the last place I need to get to. I actually started this, I had some children who were struggling to understand this, and I want to just show you the lesson. So here's how it looks. Now, straight away on the whiteboard here, you can see the calculation done correctly. At least I hope it's done correctly. But what you'll also notice is 2 scaffolded practical resources that have got us there. What you can't see is this way the lesson started, which was just with a random roll of a dice.
Okay.
So I randomly rolled a dice, and I asked the first child to get 3 of these big blue squares, which they knew to be hundreds. They'd done enough of that. And then for a bonus point, which is funny because I didn't actually give them anything, just like for a bonus point, can you find the red card that shows that number? And those of you who are familiar with the arrow cards will know that that 3 actually reaches all the way to the right-hand end under the 4 and the 1 with 2 zeros. Okay. Okay? So just for those of you who haven't used these cards, 300, there you go. And that's fantastic. And then he rolled the dice again. He got a 4. He did the same with 10s. And then finally, he rolled a 1 and put a 1. So he made this number 3 of something, 4 of something else, and 1 of something. So real understanding, real giving meaning to that 3-digit number. And then the little girl did the same thing. She rolled her dice and repeated it. And then I said, how much have you got all together? And they weren't sure, so they shoved it up together. And then we counted, and then we wrote that down as well.
Wonderful.
And so now notice we end up where the formal learning will end up. But we didn't start there, and I think that's what they know. In fact, you might say that's a bit circuitous. But actually, to be honest, I think if there's anything I've learned from looking at maths in Singapore, it's this. The higher you want to build, the deeper your foundation needs to be. And maybe I'll finish with a quote from Abraham Lincoln, who said, if you give me 6 hours to chop down a tree, I'll spend the first 4 hours sharpening up my axe. Because that's the quickest way, right?
Exactly.
And so what you'll find if you go into a grade 1 lesson in Singapore, they're like spending a whole lesson thinking about the number 5. Like, what? But this is great because now they understand it. Now they're building on rock. They're not building on sand.
Right. You can move forward with that because you've got a deep understanding at the base.
You can. You can. So they're doing the opposite of rush through. They're doing build your base first. Tie your shoelaces before you go out.
Yes, yes.
Okay. All right. That's it. Now, question time?
Time for questions. I think people will have a lot of questions. I have questions. I'm going to ask you some questions.
Ask me a math question. I've got some paper I can work
with. So, we'll have you send your question. Please send in any questions or comments that you have about the content and the ideas put forward by Andrew today, because I personally, and I'm sure you have as well, found it absolutely fascinating and made me think about some fairly fundamental issues. To activate the learning, really activate the learning and the deeper understanding. So we'll give you about 20 or 30 seconds. And in the meantime, I'm just thinking about the numbers. I learned, in primary school we had an abacus, okay? When I was 5, I think it was 5 and 6, we used abacuses, and we do. But it was only that. We didn't have any play maths, we didn't have any, and then I got into, say, mid-primary, and we were doing all these calculations in our heads. There was an awful lot of calculation in our head. We had to be what was the calculator, and then now the computer. Yeah. And I don't know, my question to you is, do you think that there's a place for that still in, the idea of,
mental calculation.
For mental calculation, for, playing acrobats, in a way. It's not just you've got it all there in front of you, but that you have to, because maths is so abstract, that a level of mental activity needs to be there as well, no? So my question to you would be that, is there a place for the kind of learning that I did as a primary school maths student?
There is.
There is.
The thing to be here is realistic and pragmatic.
Yes.
I was once, at the age of about 11, I was caught cheating. I had an electronic calculator, and they were quite new in those days. And it was back in the 1970s, and I just kind of quickly worked out an answer. And my teacher came and quite rightly told me off for cheating, and he said, there's no point. doing that, you won't learn anything. You know, you've got to learn to do these. It's not like everyone's going to be walking around with a calculator in their pocket.
Yes.
Now, 40 years later, and everyone I know is walking around with a calculator in their pocket on their phone. And actually, it depends what the maths is. You see, if I see something and it costs £2.57 and I want 38 of them, you know what? I'm just going to get my calculator out.
Yes.
But on the other hand, if I'm thinking how many of these have I got enough for 2 lattes, I don't want to get my calculator out.
No.
So I think mental arithmetic is really important. I really do. And for a couple of reasons. Firstly, ease of life.
Yes.
And not being, ignorant of
it's kind of
what
numerical
sounds good and what
literacy,
doesn't.
isn't it?
Yeah, I mean, just even as basic as, congratulations, you've been selected for interview, you need to be here by 11 o'clock.
Well, yes.
And you've got a lot of mathematics to do to get to that interview, work out how early you need to be there, work out your public transport or the miles you're going to drive.
The application.
So, or this roast dinner needs 20 minutes per kilogram plus whatever, or money. There's so much that you need to be able to do in your head. You can't always be getting out a calculator because actually, how do you know what calculation to do?
Yes.
This is the problem. I think, I'm quite old-fashioned in terms of you should know those table facts. They are hard to learn.
They are hard.
They are hard to learn.
We learned them as it became like a chant in the end, but there were moments when I thought, why am I doing this?
Okay, well, I had a learning difficulty, and the point is, no one ever needs to know what 3 5s are.
No.
But no one. But you will frequently need to know what 3 lots of £5 is, or €5. Yeah?
True.
You'll frequently need to know that.
Yes.
Or how much money you're going to earn if you get, €3 pocket money a week. How many weeks is it going to take you to save up for so it's all about the application of the number.
The application.
And so you just have an unfair advantage over the world if you can do it.
Yes. And that's interesting because you're touching on a point that I think Bob pointed to in his talk as well, is the idea of that this learning, this knowledge is applicable to society, that we're part of communities and we interact in ways, and that, he was asking the question at the beginning of his talk, well, why do science in the first place? Again, why do maths in the first place?
I think I touched on that. It's about problem solving.
It's about problem solving.
People often say to me, why do we need to learn this? I mean, we've often thought,
yes.
I guess most of us have been in school and said, why are we learning this? And the answer is, I have an analogy.
Yes.
I go to a gym. As you can see, I don't go enough, but I go to a gym. The coffee's good and you can watch people exercise, it's all good. And there are people lifting heavy weights.
Yes.
And the reason they're lifting heavy weights is not because they think the weights are too close to the floor.
Yes.
It's not inherently useful.
No.
But it's the effect that it has on them.
Yes.
And I think this is the same with mathematics. The effect it has on your brain, learning to think in terms of structures, patterns, generalization, that's what it's really about.
Yes. And your point, the other point that, because somebody sent in a question about, the teachers that you have and the way they influence you. And you mentioned that in your case, it wasn't always the teacher that you liked, but it was the one that in some way sparked something. Yeah. I have had similar experiences, particularly in maths. I had a teacher who was, she was hard, she was, she pushed us, but at the same time she fired something, and she created these situations where we did an awful lot of teamwork and collaboration, and she pitted us against each other in a way, but in a I thought it was a healthy way. It worked for me, but perhaps it might not have worked for somebody else. No. So you also have to bear in mind, the diversity that you have in a classroom. So how, have you any thoughts on that? How do you deal with, some people are more visual, other people are more tactile, other people, don't get it. I went to school with kids who were geniuses at maths. It took me longer to get something, so I needed the extra help, the extra, maybe the teacher had to use other strategies to reach me.
Okay. There are a lot of things to say on that.
Yeah, I know there are, and we don't have a lot of time.
How long we got?
Well, we've got about 5 minutes or so. Yeah.
Okay.
Yeah.
All right.
I think it's important to bear in mind, because You imagine that, I imagine that people attending this webinar are in different school contexts, and they possibly have large groups, and there are, you know, different abilities in those groups.
Okay.
Just some thoughts, not a long, you know, I know it's a deep subject, but...
It is a deep subject and quite controversial, because a few years ago there was this, the big thing was learning styles, you know, and I'm a visual learner, as though you weren't anything else, and that's actually largely been debunked. I think what we all need is quality first teaching. We all need, but just before I go to that, let me just touch on the like thing. I think it's the respect thing that's crucial, not the like thing. I think if a child senses that a teacher respects them, that's part of the battle, and believes in them. Now, there's another myth around what's sometimes irritatingly referred to as the math gene. Have you heard this? Oh, I just don't have the maths gene.
Yes,
this is nonsense.
I have no talent. I wasn't born with it, so I can never acquire it.
Nobody was born with it. You know,
no.
we all have the inherent ability to understand pattern and structure. We recognise when we're born, we already understand basic mathematical ideas like scaling and zero, and not zero. Because you know, a child is conscious that the parent is there or not there. That's the first thing I noticed. And the second thing is when a parent walks towards a child, you'd have thought, wouldn't you, the child would go, oh my God, they're getting really massive, that's terrifying. But it doesn't. There's this scaling seems to be innate. So there are some things you know from the beginning. No. There are 5%, people don't know exactly, but a rough estimate is 1 in 20 people have a genuine neurological disorder called dyscalculia, which allows their brain not to understand number.
5%, you say?
The jury is out.
Right.
5%
don't
is what
understand
people
at all
say.
how...
They can't understand number. Okay. And the structures of number. So
how do you reach those people then?
It's very, very difficult. It's not something that that can be cured. I'm doing some research on this at the moment, actually, and I'm working with a gorgeous little girl in the north of England and her mum whenever I'm up there. And it's not that she's stupid, it's not that she's otherwise unable, but the brain doesn't make those crucial connections. So I think, in terms of a diverse... I mean, let me say that any class with more than one child in it is a mixed ability class. All right, whatever we want to say. We all can learn visually, we all can learn through auditory, we all can learn practically and kinesthetically. So don't fall into the trap of saying, right, this is for my auditory learners, this is for my visual learners, as though, you know, that was a thing.
Exactly.
So actually, my advice is to give everyone a CPA approach, give everyone the opportunity to use the correct language. So we're providing them with models to think about and words with which to do that.
Great. We have some questions from the viewers. Thank you.
There was a technical issue, sorry.
Yes, no, that's fine. Monica is asking, how much training do you think an average English teacher should have in order to be able to teach using maths? To be able to talk about maths.
Okay.
Is there...
Well, okay, so
I know there isn't going to be a mathematical solution.
Yeah, Monica, you won't like this. You won't like this, all right? I trained to be a teacher for 4 years, and I was a teacher for 20 years, and I'm more or less just starting to get the hang of it. So that's not the answer you want, and not a very helpful answer. A more practical one is, I've actually been talking to Macmillan about a possible training program. Okay, and I think... to get the best out of anything, and Max Math is certainly a good thing. I didn't write it, but I see what it's based on is good. Imagine you get a Ferrari, someone gives you a Ferrari, but no car keys or driving lessons. Okay, then however brilliant a resource it is, it's gonna. I mean, if you put me in Lewis Hamilton's car, it will not be very pretty. Okay, it will be a disaster. And so I think. You need to be in an environment with someone who is an expert who will give you, I'd say 2 or 3 days probably would be as a ballpark figure. Yes. But that's the initial. I mean, we all know that we still learn.
It doesn't stop there.
No, it doesn't. We still make mistakes, and we should. You know, good teachers make mistakes. Yes. Great teachers talk about those. So I mean, I'm still learning. I still make mistakes. I made a mistake yesterday. Luckily, I had the session again, so I could, repeat and do better. So, I'd say initial input, I'd look at 3 days.
Yes, and continuing collaboration.
That's the secret. That's the secret. I've seen a lot of people, and I myself have learnt something, and then I've had a go at it, and it's fallen away.
Yes.
I had this mad idea that I could memorise the order of a pack of cards, and for a brief moment I could do it. And then a week later I couldn't do it because I hadn't practiced and kept it up. Like with a Rubik's Cube, when I was a teenager, I could solve a Rubik's Cube in a couple of minutes. I can't now. Okay. Not because I'm not clever, I just haven't kept it up. So yeah, you're right, ongoing.
Okay, there are 2 other questions. How much time do you recommend should be spent on the concrete part compared to the pictorial abstract in the classroom?
Great.
Is there a kind of balance that you should...
No, there isn't. That's a really important question, and it allows me to address this. Concrete is what happens at the beginning of a concept, and for some children that'll take 10 minutes, and for others it'll take 10 days.
Sure.
And so what I recommend is you have the resources available, and don't use language like if you need them. Because that's a little bit, no one else. Just have them available on the tables, and then children naturally and gradually start to be able to articulate and get a sense and move away when they're ready. So don't put a time limit on that.
Great advice. Very good. And a last question. Somebody is asking, Anna, thank you, Anna, what is the future with AI? Alexa, for example, to work constructing the algorithms?
Okay, I'll just find out.
I don't know. I couldn't answer.
I'll just
that
find out.
question.
Excuse me.
Yes.
Alexa, tell me how to teach my lesson better. Okay, I think we're safe for now. You see, I'll finish where I started. Teaching is a craft.
Yes.
Okay. AI doesn't yet have the ability to respond in a nuanced way to 30 different children. So while I'm not by any means against technology, and in fact if it wasn't for some amazing technology in this room and some amazing people managing it, we wouldn't even be having this conversation. But actually, technology is the tool and not the master. I think the teacher-child relationship will continue to be paramount.
That's wonderful. I think we all agree with you with that. Fantastic. Thank you so much, Andrew.
Pleasure. This is fun.
People are saying thank you, great ideas, thank you for your motivation.
Welcome.
Yeah, and really it's an eye-opener. And I think both you and Bob are saying similar things, really. Make it active, involve them.
It would be awkward if we were saying opposite things, I guess, wouldn't it?
No, but you know how important it is. But at the same time, having expertise that the teacher's role is key. Yeah, you know, there have been tendencies of late to sort of say it's all children-led, you know, children-centred, but there needs to be, the role of the teacher is paramount, but it's how they manage it.
It is, the teacher is the expert in the classroom initially, yeah.
Yes, fantastic. Yep. Okay, well, thank you very much.
That's a
thank
pleasure.
You so
My
much,
pleasure.
Andrew. And thank you to all of you out there for attending. I hope you've enjoyed this experience. I said earlier at the beginning to post a comment on our Twitter account. Please do that. We'd love to hear from you. Also, I would like to say that we will send an email in the next couple of days with the handouts of the 2 sessions today, summarising the main points, the main ideas put forward by Andrew and Bob. Also the recording of today's event, so you have the opportunity to revisit the ideas again. I certainly will. And also a certificate of attendance. So you will receive that email in the next couple of days. And finally, I would like to ask you all to complete an online survey that will now appear on your screen. It's very short. There are only a couple of questions. And the reason why we're doing this is that we want to continue to offer you these online events. And in order to do that and to make them as good as possible, we need feedback from you. So we value your opinion. There are questions on the day, the time, the relevance of the talks, and also an opportunity for you to suggest topics for future sessions.
The shirt. I want to know if you like the shirt.
So please do give us your feedback. It will make a difference to how we run these events in the future. And so that's it. Thank you to Andrew. Thank you to Bob. Thank you to you out there. Thank you to the team here, and hope to see you again at one of these events in the future. We hope that you have found these teacher training videos of real use and relevance to your classes. We would like to remind you that you can find many more practical teaching ideas and tips, articles and video clips in Macmillan Advantage. Don't miss this opportunity to continue your professional development.